So in this session, we are going to start with a new topic, that is dynamic programming. Okay, so our topic name is dynamic programming. It's a very important concept for programmers and many questions are asked on this concept, right? So it's one of my favorite topic, right? So let us start with the topic. So dynamic programming is all about two things, of which one of the thing we already know, that is optimal substructure. It will be applied. It's kind of an algorithm which will be applied in a problem which has optimal substructure. I will tell what it is, and which has overlapping subproblems. Okay, optimal substructure we already know. We have studied it in detail in recursion. Optimal substructure is my problem can be solved if I know the answer of smaller subproblems. If I kind of know answer of smaller subproblems, I can solve my problem. That is what is optimal substructure. Okay, so wherever you apply recursion, that means your problem is depending on smaller subproblem. That means it is following optimal substructure property. Okay, so dynamic programming will apply to the problems which has optimal substructure property. Okay, for understanding overlapping subproblem, let me consider an example of the problem which is one of the most common problem, and we have already did that in recursion. That is calculating the nth Fibonacci number, right? Nth Fibonacci number. So calculating nth Fibonacci number, its code looks like something like this. You have to calculate nth Fibonacci number, right? And you do give me the answer of Fibonacci of n minus 1 and give me the answer of Fibonacci of n minus 2. Then my answer will be answer 1 plus answer 2, and you return this my answer. And your base case is if n equal to 0 or n equal to 1, you will return n. So if it is 0, you will return 0. If it is 1, you will return 1. So this is kind of a code. This is a recursive code for calculating nth Fibonacci number, right? So whatever your recurrent solution, that means that is your optimal substructure, that your nth Fibonacci number depends on nth minus 1 Fibonacci number and n minus 2th Fibonacci number, and that you have applied through recursion. This is called as optimal substructure property, that your nth Fibonacci number depends on n minus 1th and n minus 2th Fibonacci number. You can apply that, and if you know the answer of this and this, you know the answer of this. Okay, so your problem depends on smaller subproblems. Now for understanding overlapping subproblems, let us understand what is happening in recursion in this case. Okay, so if you are calculating 5th Fibonacci number, you want 4th Fibonacci number and 3rd Fibonacci number. For calculating 4th Fibonacci number, you want 3rd Fibonacci number and 2nd Fibonacci number. For calculating 3rd Fibonacci number, you want 2nd and 1st. For calculating 2nd Fibonacci number, you want 1st Fibonacci number and 0th Fibonacci number. This is your base case, you will stop. When you will come to this 2, you want 1st Fibonacci number, you want 0th Fibonacci number, right? Similarly, here, you want 2nd Fibonacci number, you want 1st Fibonacci number here. You want 1st Fibonacci number and you want 0th Fibonacci number here. Okay? So overlapping subproblems arise here because you are calculating 3rd Fibonacci number here as well as calculating 3rd Fibonacci number here. So you are repeating these calls. This 3 and this 3 is repetitive call. This 2 and this 2 are the repetitive calls, due to which its time complexity becomes what? Its time complexity becomes order of 2 to the power n. We have calculated in recursion the nth Fibonacci number using recursion. You calculate in order of 2 to the power n. Why? Because you are calculating the same subproblem again and again. So this is one subproblem, this is another subproblem, this is another subproblem. All of them are same subproblem. So these are known as overlapping subproblems, right? In dynamic programming, we do not calculate this result again and again. So you have calculated 2 here, you will not calculate here. You have calculated 3 here, you will not calculate here. So all of your calls will become unique. All of your calls becomes unique. And if that happens, your complexity becomes order of n. Right? Why? Because just see, you were